I'm an organizer, but there is a notice here. After the meeting, before you leave, please return your simultaneous interpreting headset and take all your belongings, because once you leave, you cannot come back again. And we will clean up the meeting room when the conference ends. Please follow the instruction of our followers, and please get down from the escalator to the third floor, and then you can take an elevator. Okay, time's up. Let's get started. The last session. Thank you all for joining us, and I hope you can get some useful information. We are from a company from Beijing. It's called 联合沉淀 and TrustChain technology. My colleague and I will talk about the blockchain and IoT related technologies. So first, let me give a brief introduction, the project background, our company background, and also the background infrastructure introduction and the details. I will focus on the achievement of Oracle. And our team is from Beijing Aerospace University. It started blockchain in 2014, and we hope actually they have implemented a lot of national projects, and we want to commercialize it and industrialize it. So actually, this is mainly from BHChain private, and we hope we can participate in the Hyperlayer community and other communities. And we hope, and through the power of university and the power of community, we can build an enterprise level blockchain product. And I will give more introduction later. And today, I will talk about the combination of blockchain and IoT. And blockchain is used in three scenarios. First is cooperation. Second is value and achievement. So we say on the internet, there aren't a lot of trust mechanisms. It's mainly rely on personal credit. So how can we use blockchain to enhance edge? There are three parts here. First, we need to have edge trusted security. It's not directly linked to the blockchain. Second, for example, how can we circulate the data circulation of value through blockchain? And on the edge, how can we implement strategies? For example, the decision making are not necessary on the cloud. Maybe you can do it locally. So maybe we can use a smart contract. These are the three main topics. First is edge trusted security. Second is the multi-chain structure, and also smart contract. For our project, we have this structure. We talk about intelligence under the scenario of IoT. There are two layers of intelligence. For example, a dinosaur, it has a major brain and a minor brain. In a large system, we have a similar layer. For example, for the major decisions or analysis, if we put them all in AI or in cloud, it's not appropriate. And how can we ensure that the data you send to AI is true? For example, for autonomous driving case, and you need to build a model and get the parameter. So of course you need to capture this data, and you need to do data cleansing and make sure the data is accurate, and maybe the data is purchased from elsewhere. And how can you ensure the quality? And maybe you also need to do something, and you need to make sure the truth of this AI, of the data in AI. And the second is about intelligence. The core intelligence is from AI for decision making or inference, etc., or basic rules. And for example, the industry rules, we hope we can achieve it at the edge. So these are the two layers of intelligence in business IoT. When we do blockchain, we often talk about where do trust come from. First, come from a consensus. For example, Bitcoin, it's from consensus or some algorithms. And the second is from Internet of Things. And if you want to fix something, it's high cost for. Actually, in Internet of Things, if you want to manipulate data in the machine, the cost is high. So there are two layers of intelligence. And at the edge, we mainly talk about smart contract. This is the scenario we designed for a project. For example, for each factory, they have a chain. And for the chain, they are in different location. They have different algorithm, maybe etcd or wrapped algorithm, or PBFT, POET algorithm. This is the logic of BIoT platform. As mentioned before, there are several layers. At the bottom layer, we have entry. We use or input. We use TEE technology to make sure the data is trustworthy. And the second layer, we use the smart contract. But this smart contract is run in the blockchain. At the upper layer is the control layer. And between the master chain and the sub chain, they need to control. And the other side is the business side. They have the model or data. So this is the logic of the BIoT platform. This is the infrastructure structure referring to NFV. This is the trust network, and the architecture is referring to NFV. The difference is that on the left side, VANF part is achieved through blockchain, and the management of chain by blockchain is achieved by another technology. We have the primary version for all these. And we will also combine Kubernetes. And on the top part, we have a lot of cases. And then the upper part is the business systems. This is the infrastructure details. You can have the central plane. We will integrate KubeEdge control and combine a lot of KubeEdge projects. And we have these components here, for example, HD. This is the blockchain architecture. So it's like a parent-child relationship. We have the base chain. We have our own TrustChain. And we'll also use other, for example, sawtooth and tendermint. And in every blockchain, identity is a very basic part, no matter for the management of person or things. And of course, for chains, it's not enough. Management of chain is not enough. For example, it's mainly for the values. But if we want to implement it, we need to consider existing scenarios. How can we connect with the edge gateway, etc.? Of course, this is a big topic, and also database cannot be put on the blockchain. And in blockchain or its backup, then if you put all the database in the blockchain, it's impossible. So for database, you need to put in a IoT database. So we need to achieve a trust base. And third is a trust storage, about object storage and combining the blockchain. And we also need to have a mechanism for the communication of chains. And we have the trust stream and the trust pay. So it can connect with the existing payment systems. This is the blockchain architecture. This is a tool stack for developers. It's mainly used in our company internally because we don't have a big community yet, and it provides a quick deployment for the users, and it can be deployed in the production. And we use Ansible and Docker. First is the through Docker orchestration or using Ansible. So it's like a one-key deployment. But before that, you need to do a lot of things. For example, what kind of chain you want to deploy, how do you deploy the network or IP address. In different chain, maybe there are different scenarios. So before deployment, you need to do the environment pre-check and whether the network is available. And after deployment, you need to do the post-confirm. We can support a lot of solution. For our company, it's an independent product, but for developers, they can also use this tool to do fast deployment. This is the tech arch. As the bottom layer, this is the deployment, monitor, and operation. These are the key technologies, for example, control algorithm, P2P network, node management. and we can have a node dynamic management. It's done through the smart contract. And in the middle, we have the cross-chain protocol, etc., to extend the chain. And this is a feature of BH chain. On one hand, we can write codes like solidity, and we can also do WSM, and we can also do modeling. For example, we can do spin and model checking to check whether this model is valid. Then we generate the code. So this is thanks to the accumulation of technology from university.
And here are our processing and storage of the data. And after that, we have the details regarding the technology. First, how do we realize a state machine replication, a plugged consensus algorithm? For now, we have seen a lot of algorithms such as POW or FBFT. There are a lot of similarities, and we have a way to unify different algorithm. I think there are two-phase state machine replication. For blockchain, whether it's POW or FBFT, let's talk about POW. POW use Bitcoin as an example. Across a Bitcoin network, a lot of people are mining, and you will see a light lighting up or lit up, and then you can see the node for writing down on the ledger. Academically speaking, this is called the state machine replication. That's how Bitcoin works. And then let's go to the byzantine algorithm. For example, EOS. You need a few nodes. As for the choices, the selection of the nodes, it could be random, it could be through election, such as VIF, and the nodes will form a cluster. Once you finish this process, they will again carry out a state machine replication. That's why we have two phases. In the first phase, the master nodes will replicate all the states. And logically speaking, we can think they are the same nodes, because for distributed system, we talk a lot about a single process. And it's across the network, we have seen two-phase replication of state machine. So we want to find a consensus algorithm, for example, for Bitcoins. So that's how we manage those nodes. And once we select those members, there could be quite a few nodes working on the block. This is the first phase replication. And then you will have two roles. One is witness, the other is the builder. And then the third phase is to make blocks and then replicate. As for the features of the blockchain, they use different rounds to generate the blocks. And as long as you can control all the links, you are able to change the consensus algorithm before it goes into the next round. And this is what we do for is payment, external payment. In the orders, there will be generating a random code, a random number. And the one difficult thing for the blockchain is to generate a real number. For example, we have referred to the POET number, and we'll expand that to different ways of verification. And then we put that number in the order. Just like we see on Alipay, it's not very complicated. And this is a distributed time series database. We use a database, a time series database, which use a lot of logs. It has different distributions. We write different logs and then put them in the blockchain. For on each node, we will see the distributed ledger, which cannot be changed. And this is next time I'll give it to my co-speaker, Mr. Jing Shuai, and he's going to talk us about the forecast machine. People may think this is, or we call it Oracle. It's very, very popular. Blockchain is a closed-loop system, and it's hard to break through the access offline. For public chain, if you want to go through this bottleneck, it's going to be difficult. However, when we are working on special cases, for consortium blockchain, we are able to realize the visit between the two types of blockchains, and I think it's an important tool. For oracles, simply it provides some capabilities to go from on blockchain to off blockchain. And this is for us to make some system a circuit, because the because in a lot of projects we have seen a lot of traditional set of data. It's hard for us to manage all the data on blockchain, on the chain. So there are many types of oracles. The first is software oracle, second the hardware oracle. And for the software oracle, maybe you have heard a lot about Oracleize. It's based on the TLS protocol, and based on the TLS, there is a key, and it's a coded tool for people to visit. For example, Ali server. If you use TLS 1.0, 1.1 protocols, in this process, they will use a verify code. And because we use Ali servers to do the negotiation, you can't really change any data here. If you use a verification, it's trustworthy to visit the off-chain. And now if we use Intel GXG, whether it's for the process or the operation of this process, it's hard for you to break through the security limitations. Another type of oracle is consensus oracle, which will require you a voting. And this is based on our nodes. The last type of oracle is inbound and outbound oracle. As for the oracle, we all know that in the consortium blockchain there is a superface concept. For our supernodes, they are generators, and we use a consensus for our oracle. What we do is on VM, if you understand the Ether party, you must know the VM standard and this a very limited visit or access, and it has very strict control on off-chain visits. So we want to break this barrier between on-chain and off-chain. We want to use a VM to achieve off-chain visit. This is something we refer to traditional systems, for example, WSCM. When they use the external system, they use EVM, and we extend on the EVMs and then add in the system contract. It's similar to WSM, and the contract we provided is a limited. However, the resources are controllable. It's specific for consortium blockchain, and it's something we do with a controlled environment. So what I want to say is that how we expand from VM to EVM so we can achieve external visit beyond the chain. If you have seen the EVM standards, there is a call interceptor. That means from our own contract to use and transfer on the other contract and then send the feedback of the result. That's very similar to the ordinary function transfer. So based on the call interceptor, we have done interception. This a categorization on normal call, and this is a limited visit on the on-chain resources, and this is how we achieve the resources transfer on our own system. Here you can see an intercept. Of our call quality, because EVM is a very light cluster, and you can see this is how we transfer the execute called channel, and this is an episode of that function. And once we change this part on the traditional transfer, and we did an interception and differentiation, and here we had some standard programming. This is how we use the interceptor. Because to address the only index for this contract, so we use the index to differentiate the contract. So this is contract router. On contract router, we have to control the resources. As there have many different system contracts, we use a contract router to route system contract call. The contract router API are register, table, a get handler. That's how we achieve the specific realization. This is our core, the contract handler. But when the processing a call request, the handler will decode the input params and execute the native function to get the off-chain data. As the solidity input param and return value is already encoded, we then must use a code to decode and encode the data. We must break through the solidity limitations, and we request the processing flow. The contract handler, when we develop the solidity contract, this is only the partial encoding process. So the two cores is function, reflection value, decoder, and encoder. This decoder and encoder are able to change the param into the local value we will need.
So here I have two encoding specifications. So one is a function selector, the other is dynamic types. So for that part, you need to have a method selection. And for example, so you need to have a selector. So for example, selector for function test, and then we will reference to SAT3. And for dynamic types, the encoded value of data will consist of two parts: data length and data content. So the format is like data length and data content. And for the specifications in detail, you can refer to the internet, and you can find more details. And you can see this ABI decoder and ABI encoder. And this is what we are planning. Actually, in contract for all the operations, you need to do the consensus validation. We have Oracle, and we will combine with a cross-chain agreement so that we can have cross-chain transactions. So with Oracle, we can consider much less in our agreement. So this is something we are considering. This is the structure. Now I will give back to my colleague for the wrap-up. This is the multi-chain overall structure. So maybe you're familiar with this structure. And we have modified the system call, and we change it into hypercall. And actually, at the solidity or encoding, we need to do a lot of things. But overall structure, it's like this. And for details, maybe we can communicate afterwards in detail. And let's have a quick conclusion. We talked about two-layer intelligence BOIT platform solution and cloud edge infrastructure design and implementation, pluggable consensus framework, TAE and trust-based Oracle technology, and also chain extension. And last part is our open source address. Okay, the floor is open. For blockchain, will it be slow? And just now we have mentioned about different algorithms. So yes, for Bitcoin part, it's slow, 10 minutes. It's like a Fabric 0.6. This is byzantine algorithm, and it can reach about 2000 US. It's around 2000, and our real performance tested is around 2000. how do you manage identity? This is to implement the DID contract, and this is achievement through business. And for personnel, it's more of a personal ID or iris or fingerprint. So in the smart contract, you manage it because this is a global service. So you use the edge computing and also blockchain. Do you have specific applications? We are working on an industrial chain. There are two projects. The first is BUA, and this is the industrial chain project. And we also have another project, also industrial chain, and it's mainly about data capturing and uploading to the chain. For the data, where do you treat it? At the edge, we don't do a lot of things. For example, we have some algorithm there, and data cleansing, we have some algorithm. And then for the rest, we send to the cloud. So you just combine the blockchain. So make the data more trustful. And for the edge node algorithm, for example, data cleansing and the data analysis, what kind of technology do you use? There are two parts. First is the smart contract is done in smart contract, and the other is done before uploading to the chain. So this is more like a big data cleansing. Where do you operate it? An edge node. Edge node is at the local gateway. So it's in the IoT device, yes, before sending to the cloud. Actually, we first connect to the chain, then upload to the cloud. For that part, it's not closely related to the chain. Sorry, we cannot hear without microphone. Actually, there are two layers. First, we have the base chain to manage all these chains, the local chains. So the algorithm, the computation is on the local chain. Yes. And for the smart contract is in the smart contract machine. And another part is algorithm before loading to the chain. For your existing project, all of them are using the technology or partially. Actually, there are a lot of technologies are not that mature. And for one project, for example, the Oracle technology, but for the project, we do hope that we can have real implementation. For multi-chain. We are in the primary stage, but for Oracle, it's more kind of mature. We can have a call across the chain. Can you talk about zero knowledge more? In the Alipay payment process, first we will generate a random number. Actually, as we all know, the information on chain is public. At the very beginning, we don't have this part, and some people say that if you use the Alipay bill, and then you upload it, we cannot accept it, and it will disclose my personal information. If we do analysis in detail, when we look at the Alipay, when you develop Alipay, it will return to you the payment result. It includes personal information, so we just use zero value to validate that I really transfer 5 yuan. But for the details of transfer, for example, who transferred, who received this information is not included. So for Alipay's, all the information is stored not in the chain. We will capture some abstract info, and they cannot refer to the info not in the chain. It's down below the chain. Then on-chain part do not include this. Any other questions? Okay, thank you all.